Okay, in this short video, we're going to start the second type of tissue called connective tissue. Now, we covered epithelium in a first video, and one of the things that I wanted to remind you of is the difference between epithelium and connective. When we did epithelium, what we went over was a whole bunch of cells that were closely packed together, right? So if I were to draw this out, let's choose green, we could have a bunch of cells like this that are closely packed together, whether it's one cell layer or whether it's multi-layer. Notice the cells are very close together. There's very little gap or space between them. Very little what we call ECM. ECM is extracellular matrix, right? Because the cells are so closely packed. But connective tissue is where we have cells that are not so closely packed together, and they could be a variety of shapes. They could be proteins, they could be strings like this, but notice that the cells that make them up are not closely packed together. There is lots of space between them, right? There's lots of extracellular matrix, but not so much with epithelium. That's a big difference microscopically. So connective tissue consists of widely spaced cells separated by protein fibers and ground substance. Protein fibers and ground substance is called extracellular matrix, ECM. Now, connective tissue is the most abundant and variable type of tissue in the body. It's found in all parts of the body, and it functions to connect organs together. It even connects the epithelium to the rest of the body. Connective tissue can support and protect us both physically and immune system wise, and that's because when we think of immune system, we're thinking of blood. But when we talk about blood, we have red blood cells, RBCs, and then we have white blood cells, WBCs. And part of the WBCs, part of them, these B cells, right? We also have T cells, but B cells evolve into plasma cells, and plasma cells produce antibodies, and antibodies help our immune system, okay? Red blood cells, on the other hand, although they're blood, their primary job is to carry hemoglobin, and hemoglobin is going to bind to gases like oxygen, carbon dioxide, and nitric oxide. Connective tissue is also involved in the storage of energy and heat production because of adipose. Whenever you see the word adipose or adipocyte, these are fat cells. Adipose are fat cells. And connective tissue is involved with the movement and transport of materials within the body because of blood. So let's look at the mapping of connective tissue. I've seen this show up on past quizzes as well, where you were dragging and dropping the three main categories. So under connective tissue, we have one category, which is connective tissue proper. The second category would be supporting connective tissue. And the third category would be fluid connective tissue. Now, under fluid connective tissue, that's pretty easy. We're just talking about blood, right? Red blood cells, white blood cells. Under supporting connective tissue, the key word there is supporting. When I think of what type of tissue supports the body, I'm thinking like bones and cartilage. And when we talk about bone, we'll be talking about compact bone and a little bit about spongy, but a little bit more focus on compact bone. When we talk about compact bone, we'll be talking about something referred to as an osteon, which under a microscope, the osteon looks like someone chopped down a tree where it has all those layers and layers and layers. Under cartilage, cartilage has three different flavors: hyaline cartilage, elastic cartilage, and fibrocartilage. So I'll break these down into more detail. And under connective tissue proper, there's loose and dense connective tissue. Under loose, we have areolar, we have adipose, and reticular. And under dense, we have three types. We have regular, irregular, and elastic. So it's important to kind of have an understanding of the flow chart. So let's look, we're going to look at connective tissue proper. So we're going to look at loose and dense connective, right? Loose and dense, you can see that here. So loose connective tissue, we have areolar, adipose, and reticular. Areolar is the padding that separates the skin from the deeper tissue. So if you were to pinch the skin of your forearm near your elbow, when you pinch it, you can't pinch the muscle. It actually separates the skin from the muscle. And it's made up of elastic and collagen fibers. Elastic gives it more flexibility and elasticity, and collagen fibers give it more structural support, like for strength. Adipose, basically fat cells. And fat cells under a microscope, they look like a squamous cell, right? A squamous cell looks like this with a nucleus in the center, but a fat cell looks like a squamous cell, but the nucleus is here. It's towards the periphery, okay? It's off to the side. And then reticular is also loose connective tissue. It really provides the framework of support. So you see lots of stuff like this when you see reticular. It kind of looks like meshwork like that. Under dense, we have dense regular and dense irregular. Now, dense regular are going to be when you have these collagen fibers like this, they're running parallel to each other. So they're packed nicely and densely, and they're in alignment, okay? So that's tendons and ligaments. We need to make sure that these fibers run parallel to one another. When we have dense irregular, we can have a collagen fiber this way, we can have a collagen fiber this way, and a collagen fiber this way. They're not necessarily running parallel to each other. And then elastic connective tissue, we see this with certain ligaments, especially those of the vertebral column, where the spinal column is very stable. In my over 25 years in practice, I've seen mild misalignments of vertebral segments, but I've never seen a dislocation of one. And that's because ligaments are going to hold one bone and another bone. Ligaments are going to hold them in alignment. So ligaments go from bone to bone. Those are ligaments. You can have ligaments holding bones to bones. But because the spinal column is so stable, the ligaments of the spine needs to be flexible, and this elasticity gives it the flexibility. Okay? All right, so now we've covered the loose and the dense. Now we're going to look at this one here, which is fluid connective tissue. So we're going to look at number 3 off to the right, fluid connective tissue, which covers blood. Now blood, we have RBCs, which are red blood cells. We call them erythrocytes. And you heard me say earlier that they carry hemoglobin, and the job of hemoglobin is to carry gases like oxygen, CO2, and nitric oxide. The white blood cells, or leukocytes, leuko means white, these are the warriors of the body. These are the soldiers. They're going to help us fight infections. You're going to hear terms like B cells and T cells. B cells evolve into plasma cells. I'll put a P for plasma cells. And then these plasma cells can evolve into A for antibodies. Okay? Platelets are going to be involved in helping us stop bleeding, so we call that a thrombosis or clotting. The other type of fluid we have is lymph. Lymph is interstitial fluid. Interstitial means it's between the cells of the human body, and they're going to enter the lymphatic vessels. That's interstitial fluid. Okay, so now we're going to be looking at this column here, which is going to be the supporting connective tissue. So we're going to talk a little bit about cartilage, and then we'll talk about bone, okay? So cartilage is avascular. Now, when we see vascular, vascular means blood supply, a means without. So cartilage is avascular, and that's why when you have cartilage damage, it's really hard to heal that because it does not have blood supply. So it's going to get all of its nutrition from synovial fluid. Synovial fluid is the lubricating liquid that's found between two adjacent bones. And when you have two adjacent bones that move, it's called a joint. So synovial joints have synovial fluid that circulate nutrition to help nourish these cartilage cells. Cartilage cells are found on the ends of bones, especially hyaline cartilage. Okay, hyaline cartilage is made up of type 2 collagen. So we have type 2 collagen and type 1 collagen fibers. Type 1 collagen is used to nourish fibrocartilage, but I use a type of supplement that I put into some of my drinks that have type 2 collagen fibers that keep all of my joints super healthy. From years and years of powerlifting through the years and years of manual medicine, of chiropractic, working and moving patients all these years, I am truly blessed to have fully functional joints. But I do the proper maintenance and management of them. I'm very big on supplementation. Supplementation does not mean substitution. Foods are always best, but I do know that many foods that I consume and with the diet that I consume, I may be lacking some vital nutrients. So I have no problem at all supplementing them. So one of the things that's very important, and I have people tell me, Doc, your skin, it looks so young, you have no wrinkles, right? It just so happens that, you know, skin is made up of collagen. So hyaline cartilage is the most common type of cartilage. It covers the ends of the bones, every movable bone from the shoulder joint, the elbow joint, the wrist joint, the finger joints, the hip joint, the knee joint, every freely movable joint. The two adjacent bones coming together has hyaline cartilage, and that is made up of type 2 protein. So if you're not consuming enough protein in your diet, you may not be getting enough collagen. Or if you don't have the right digestive enzymes in the stomach to break down the protein, you can't get collagen. Okay, so what's the second type of cartilage? Is elastic. Elastic cartilage allows for some tissue flexibility. We have some elastic cartilage in the ear. We have in the external ear, called the pinna of the ear. We have, or the helix of the ear. We have elastic cartilage in the inner ear, called the eustachian tube, and also the epiglottis, which is the flap and back of the throat that when you swallow food, that epiglottis folds over to cover the windpipe so food doesn't go down the wrong pipe. So that's elastic. When we talk about hyaline cartilage is found on the ends of bones. It's also found in the nose, in that nasal septum that separates the left nostril from the right. There's a nasal septum. When people say they have a deviated septum, that's hyaline cartilage. And then we have the thyroid cartilage in the throat. And then there's tracheal rings, this cartilage that goes around the trachea, which is that windpipe. Now, fibrocartilage down here at the bottom, this is the strongest type of cartilage in the body. It acts as a shock absorber. So when I think of a shock absorber, I'm thinking of what is it that we have between each vertebra within our spine? What is it called? We call them discs, right? In between here is the intervertebral disc. So those discs, that shock absorber, when we say he or she may have a herniated disc, that is fibrocartilage. The pubic symphysis, that's a vertical disc going up and down where the two pubic bones come together. And then in the knee, the menisci, the medial lateral menisci, is also fibrocartilage. But all of these cartilages are avascular once again, poor blood supply. Okay, I've seen this pop up. You have to drag and drop elastic cartilage, fibrocartilage, and hyaline cartilage to the description. So if it says here, blank is composed of type 1 collagen fibers, that's thick type 1 collagen. What did I say earlier about type 1? I said that's fibrocartilage. Type 2 is hyaline cartilage, EFGH. F comes before H. Fibrocartilage is type 1, hyaline cartilage is type 2, right? F comes before H. So fibrocartilage, 1 comes before 2, hyaline cartilage. Hyaline cartilage is type 2. It doesn't form thick bundles. And that's why people's joints can wear down, because they're not thick bundles like the fibrocartilage or the discs in between the spine. Elastic, this is a network of branching of elastic fibers, right? When I was in elementary school, I learned not to use the word in the definition. So that was easy enough. Okay, in cartilage, I've seen this pop up before. Now, this right here is hyaline cartilage, like these cells are hyaline cartilage cells, but that's not what they're asking. They're asking for the highlighted structure, which is that aqua blue. So when I opened up the lecture with connective tissue, notice how all of these cells are not closely packed together. They are separated by a matrix. So this is the matrix of hyaline cartilage. That's what's highlighted blue. Okay, we're still on the supporting connective tissue. We're going to talk about bone, specifically compact bone. And I said compact bone is the functional unit here is called an osteon. And an osteon is a group of osteocytes and concentric lamellae surrounding a central canal. Yeah, right. That's a lot of words there. What does this mean? Let me show you a picture of it, right? So this, if we look here, right here, whoops, is an osteon right there. And if you look at it, you see that we have all of these concentric rings going around. And right in the center, right here, is a central canal or a Haversian canal where we see arteries, veins, nerves, and lymph. Okay? So if we looked at bone, right, this bone right here, we're just talking about compact bone is any section of this part and any section here. That's this. All of this, the periphery of it. All made of compact bone, all throughout here. This is all compact bone. And the inside, this is spongy bone and spongy here on the inside. Okay. The outermost part of bone is called the periosteum, whereas the innermost part of the bone is the endosteum. Okay, so we have spongy bone here and compact bone all throughout here. Now, we also have, so we have these terms osteoblast, osteocyte, and osteoclasts. Now, what osteoblasts with a B, are going to build up bone. They're going to make matrix. They're going to push out cement or calcium, right? They're going to push out this matrix that's going to calcify. And when it does, the osteoblast gets trapped in its own matrix. And when it gets trapped in its own matrix, it now becomes a mature cell called an osteocyte. So the osteoblast forms the bone, and then it evolves into an osteocyte that just maintains the bone. The osteoclast with a C, this one, breaks down the bone. So the osteoblast and the osteoclasts are somewhat synergistic, but in an antagonistic way. They work together by doing opposite things. They break it down and build up. They break down and build up. They break down and build up. So the osteoclasts are going to break down old bone, so osteoblasts can build up new bone. And this is where some of the osteoporosis medications work, where they block the person's osteoclast so the cells aren't being broken down and only the osteoblasts work. So by theory, most people think that's a great idea. Hey, we can stop the bones from breaking down and only allow the cells to build up. But let's critically think here. What happens if you put new sheetrock on top of old sheetrock in a home? You put new sheetrock on top of old where maybe there's mold and mildew and debris. It's not good, right? So if you're putting new bone on old bone and the old bone is a weak foundation, they'll fracture. The bones break, and this is what we hear in a lot of women that are on these medications is bone fractures, especially of the jaw and the femur. And if you've ever heard that, oh, grandma fell, and then when she fell, she broke her hip, it's typically the other way around, where grandma was walking, the hip broke first on weight bearing, on walking. Grandma lost her footing and her balance, and then she fell. It's typically how it works. The concentric rings are called lamellae. And then there are other lamellae that do not make perfect rings called circumferential. We have interstitial lamellae. And interstitial lamellae, like when you have an osteon like this, and then we have all of those concentric rings going around it, right? Those are concentric. But when your osteoclasts break these down, you're left with remnants of the osteon, and that's called interstitial. So let's say here, these are concentric rings, but let's say right here between two of them, those are interstitial lamellae. They're interstitial. Okay, canaliculi, I'll show you where they are. Lacunae, I'll show you where they are. Periosteum, we did, that's the outer layer of bone. Endosteum is the inner layer. Okay, so here, let's see if I can show you an osteocyte. Where's our number 8? Okay, I'm going to have to draw this one out for you to help you understand it. So let's say this cell right here was an osteoblast, and it pushed out matrix, and we started making bone, and it calcified. Now this osteoblast got stuck in a cavity. The cavity that it's in, this cavity, is called a lacunae. All right, but now the osteoblast is called an osteocyte. That's it. So now that is an osteocyte that's sitting in a lacunae. And then you have these branch-like extensions coming off of it that look like cilia. Those are the canaliculi. Okay, that's all. So what is this blue highlighted structure right here? This entire thing is called an osteon. That's an osteon. What are these cavities here? The blue highlighted cavities? Those are the lacunae. What's in the lacunae? That's an osteocyte. Okay. What are the black spiderweb lines? Those are called canalicules. Those are the canalicules here. Okay, and the central canal, that's this right here, the hole in the middle where the artery, vein, nerve, and lymph are. The lamellae, especially concentric lamellae, those are the concentric rings going all the way around. Okay, okay, so in terms of connective tissue, most connective tissue is highly vascularized, right? We said the exception before was cartilage, which is avascular. Ligaments have a little bit better blood supply. Tendons also have a pretty good blood supply, but cartilage, really bad. Ligaments, probably second place. Let's say this. Let's say cartilage comes in third place, the worst. Tendons, because they're extension of muscle, are probably the best. And in second place, I'd say ligaments in terms of blood supply. Okay, so they're poorly vascular, but they're not avascular, just poorly. Okay, so remember, connective tissue has lots of non-cellular, non-living material. That's called the ECM, the extracellular matrix, and those are found between the cells of connective tissue. Good place to end it. When we come back, we'll continue with the third type of tissue called muscle tissue.